Okay, now it's time to, let me move this over, to finally go over how we solve absolute value equations. So let's look at this first one here. So the first thing is to make sure that you get the absolute value expression by itself, meaning let's get these vertical lines by itself on the left side of the equation. So first let's add 5 to both sides to, begin that, just like with an equation. So 3 times the absolute value of x plus 6 equals 27. And then be careful to not make the mistake of distributing this 3. We're going to want to divide it out. Absolute value symbols are not parentheses. They're absolute value symbols. That's why they look different, because they're not the same as parentheses. But don't treat them like that. Do this instead. So then now we have that the absolute value of x plus 6 equals 9. Okay, so now at this point, we have the absolute value expression all on one side. This is where you're going to set up two equations. We're going to have one, let me put it, I can probably squeeze it over here actually, x plus 6 equals 9, or we have x plus 6 equals negative 9. Now, well, why the hell do we do that? Well, because absolute value, conceptually, it's basically telling you in terms of a graph, how far away a number is from another number. So in this case, we're seeing the absolute value of x plus 6 is 9. So what we're trying to find is values that are 9 units away from 6 or negative 6. Or think about the other way around. So let's solve this. So I can show you how this works. So let's solve for x here, and we get x is 3. Solve this one for x, take away 6. And then we get x is negative 15. Negative 15. And I'm going to write my number line over here. So we plot a dot at 3 and another dot at negative 15. And if you figure out the point in the middle, so they're 18 units away, so 9 units before 3 and 9 units after negative 15, this would be negative 6. Negative 6 is right in the middle. And both of these numbers, 3, are 9 units away from negative 6. 3 is 9 units more than negative 6, and negative 15 is 9 units less. So that's where this 9 comes from. You're basically looking for values that are going to be 9 units away from negative 6. I might have said that wrong originally, so my apologies, but that's why we have two equations, because there's two possible numbers that are going to be the same distance on a number line, at least, from negative 6. Now, when you get to absolute value equations that are more like complex, like thinking about it conceptually is kind of hard because there's a lot of operations going on. So just be aware of that. So let's go through another one here. So absolute value of 2x plus 5 minus 1 equals 7. So begin by adding 1 to both sides. And we'll get the absolute value of 2x plus 5 equals 8. And now we make our two equations. We have 2x plus 5 equals 8, or 2x plus 5 equals negative 8. And we just solve both of these, just like a normal equation. Take away the 5, 2x is 3, and divide by 2. We get x is 3 halves, or 1.5 as a decimal. Here, take away 5, and then divide by 2. 2x is negative 13. And with x is negative 6.5. So let's number line this. Negative 6.5. And then 1.5. And in the middle of those, they're 8 units away from each other. So 4 units more than negative 6.5 is negative 4.5. Right? No, actually, that's wrong. No, actually, hold on. No, negative 2.5. Oops, that should be negative 2.5. Is in the middle. Now you're like, okay, what the hell? Like, where does that number come in play? Well, it's not easy to conceptualize unless you really think like, what are you doing? Like, oh, you're like, what numbers are 8 units away from a number after you double it and add 5? So then that's how that becomes negative 6.5 and 1.5. Because it's not always easy, like not like this one where you just care about negative 6 and what numbers are 9 units away from negative 6. This is like what numbers are when you double, what numbers are they going to be 8 units away from negative 5 if after you double it. So again, it's kind of complicated to visualize. Now let's just go over a couple more that will give you maybe some confusing solutions. Let's turn to this one. And again, advise you to like pause the video and then try the problems first on your own and then unpause it and check to see how you're doing. But of course, I'm just going to go through it right now. So let's solve for x first. So we're going to take away 16 here. We get 4 times the absolute value of 3x minus 8 equals negative 14. Divide both sides by 4. Absolute value of 3x minus 8 equals, what is that? Negative 7, negative 3.5. Oops. And then we just make our two equations. 3x minus 8 equals negative 3.5, or 3x minus 8 equals 3.5. One positive and one negative. And actually, I just fell for a trap to see if you would catch this. By definition, absolute value has to be a positive number because we think of it as like a distance, and in real life, we don't talk about distances as negative numbers. When we're in physics, we'll have velocity, and that has a direction, so it could be negative. Anyways, here we have that the absolute value of 3x minus 8 is negative 3.5. And since it's like that, we don't even continue because that's not okay. There's not going to be a solution to this because absolute value cannot be negative. There are no values that'll make this true. Well, let's carry on now. All right, J, absolute value of x minus 6 over 5 equals 12. Well, let's just go on and just remove the absolute value symbol. So we have x minus 6 over 5 equals 12, or x minus 6 over 5 equals negative 12. And we can go right on and solve this, solve these. Multiply both sides by 5. That'll cancel that. And then we get 60 on the right. So x minus 6 equals 60. Add 6 to both sides. And we'll get x equals 66 for the first solution. In this one, we start off by doing the same thing as well. Multiply both sides by 5. and we'll get x minus 6 equals negative 60. Add 6, and we'll get x equals negative 54. And then we make our number line, close circle on negative 54, and close circle on 66. Those are what, 70, they're 120 away from each other, so then this will be 6. And you see how the 6 that pops up in there? This is basically saying what numbers are 12 units away from 6 after you multiply it by like 1/5 or divided by 5. That sort of thing. Okay, let's do a couple more. Okay, that's a good one. Start off by adding 7 to both sides. We'll get 3 times the opposite value of 3x equals 9. Divide both sides by 3. Absolute value of 3x equals 3. And now we can set up our two equations. 3x equals 3, or 3x equals negative 3. Yeah. Now we just solve both of these. We'll do it all together. X is 1, or x is negative 1. And if we number line it, negative 1 and 1, the middle is 0. So this is saying what numbers after you triple them are 3 units away from 0. All right, let's do one more. For L, begin by adding or subtracting 2 from both sides. We'll get the absolute value of 4 minus x is equal to 7. Then we set up our two equations. 4 minus x equals 7, or 4 minus x equals negative 7. And take away 4. I'm doing both of these simultaneously just to get through it a little quicker. So negative x equals negative or positive 3. Divide by negative 1. Here we'll get x is negative 3. Over here we'll have negative x equals negative 11. And divide by negative 1. And then we'll get x is 11. So negative 3 and 11, they're 14 away. The number in the middle is going to be 4. And there, see, there's your 4. Okay, so that's all the practice problems I have for that for now. So I hope that helps. Let me know if you have any questions, or if maybe I went over something confusing. So leave me a comment on what you think, and a like, if you like it. And let me know if you want any other types of problems that you want me to make videos over. And make sure you subscribe, all right? Here's my dog. All right, I'll see you later.